All right, today we are going to take a number of different topics here and just to try and keep this within a reasonable time, we're just going to cruise right into this. We're looking at three different ideas here: powers of negative numbers, dividing terms, and square roots of monomials. All right, let's do it. First of all, we have to understand square roots or powers of negative numbers, we first need to really look back and understand how integers work together. So we have this expression: if the number of negative factors is even, the product is positive. If the number of negative factors is odd, the product is negative. And so what we're really looking at is we're looking at our symbols without doing any multiplication of any kind. We're just looking at our symbols and understanding what's going on here. And so I see a negative, and a negative. So there are three negatives. Sorry, three negatives. Because there are three negatives, right? The number of negative factors, it's not even in this case, it's odd. That means the product is negative. So without having to think too much about it, I can just throw a negative sign right there. Now I can just solve. I can start grouping things in a way that are going to be easy to solve. So I can say, okay, 4 times 5, that's 20, and this is 9, and 20 times 2 is 40, and 40 times 9 is 360, and bada boom, bada bing. I don't know who talks like that other than me, but I've solved this problem. And all those scary positive and negative signs really didn't matter because I just used this very simple principle. All right, so now if I look at this problem, right, okay, very quickly I can look at this and say, okay, count my negatives. 1, 2, 3 negatives. Since there are three negatives, I know the problem is going to be negative, and it happens to have the same digits. So boom, 360. Negative 360. Too easy, too fast. I guess I should have thrown another negative in here, right? Negative 4. Okay, that would be 4 negatives. 4 negatives means it's going to be positive. Still easy. Okay. Now, where does this principle come into play? This principle really comes into play when understanding powers of negative numbers. If I look at this, I know that this literally means negative 2 times negative 2 times negative 2 times negative 2. This should be times. So let's make them nice and big so we don't confuse them. So we're multiplying those. And so as we look at this, right, I see 1, 2, 3, 4 negatives, which means my answer is going to be positive, which is a little strange to think about, but yeah, some powers of negative numbers are going to end up being positive numbers. Okay, so now I just got to do the math. 2 times 2 times 2 times 2, so that's 4, 8, 16. There we go. Why don't you try this one on for size? That didn't work the way I wanted it to. Go ahead, take 30 seconds or longer if you need, and solve this problem. Magnifico. Let's move on to the next concept. Dividing terms. When we divide terms, we're going to do similar to what we did when we multiplied terms. We're going to look at the things that are the same, and we're going to combine them. Right? That's what we did with multiplication. We actually multiplied, right? So if we had x's together, we multiplied the x's together. If we had y's, we multiplied the y's together. If we had coefficients or regular numbers, we kept those together. And so we're going to do the same thing when it comes to division. If I break down this problem right now, I have 12 divided by 3. I have x to the third divided by x squared. I have y divided by y. And then I have a z squared divided by nothing, but we wouldn't really say 0, we would say divided by 1, right? Because we know that a number isn't really divisible by 0, right? To put a numerator in fraction form, we put a 1 underneath it. Okay, so now that we have this together, let's simplify this. 12 divided by 3 is 4. Okay, that wasn't too hard. Now let's look at, now we got the variables. Okay, when we multiplied, right, when we had x to the third times x squared, we said that the base stays the same and we add our powers. With division, we're going to do the same thing. Our base is going to stay the same, but in this case, we're not going to add, but we're going to subtract. So 3, the top number, minus the bottom number, right? And that is important that we keep them in order, right? It has to be numerator minus denominator. So 3 minus 2 gives me an answer of 1, but we know that x to the first is the same as x. We're going to leave it the same. All right, so now we have y divided by y. All right, don't kid yourself, you know this, right? We can still put the power up there, y to the first, right? And we could say, okay, the base stays the same. 1 minus 1 is 0. Y to the 0 power is 1. Or we could just notice that anything over itself is going to be 1, because that's how division works. We can just recognize that. So since it's going to be 1, we can just kind of, my hand just doesn't want to erase, just leave that out. And finally, we get to our last step. We have z squared divided by 1. Anything divided by 1 is what it already was. And so 12x to the third yz squared divided by 3x squared y gives us an answer of 4xz squared. Try one on your own. And if you're not quite sure what to do, just go back, rewatch this section of the video, right? Match, not this section, and do exactly what we did. Match up like terms, and remember that when we are dividing exponents, we're actually subtracting the exponents. Base stays the same, and subtract. Make sure that the numerator is always the first number. And here we get to our last concept then. Right? Terms. Terms can be broken down just as much as numbers can be broken down. We can take a number like this and we can break it down into factors. Right? I can say that 25 is the same as 5 times 5. Just like x squared is the same as x times x. Now with that principle in mind, now we can throw in this beautiful, wonderful thing that we call a square root. Now, a square root of a term, a monomial if you will, is going to work the same way as square root of just your regular number, right? If I have 144 and I'm trying to find the square root of this number, I need to understand that 144 is actually 12 times 12, which means that the square root of this, right, is just plain 12, right? 12 times 12 equals 144, and so I have that understanding, right? So let's look at this one now. Okay, we've already broken it down. We understand that this is 5 times 5, and this is x times x. So really our problem says 5 times 5 times x times x. So how are we going to take the square root of this? Well, we're going to do the same thing we did with our 144 just a minute ago. We're going to take the 25 part of it, the 5 times 5, and we're going to take one of those 5s out, because 5 times 5 gives us the 25 part. Right? And then we're going to look at the x times x, and we're going to take one of those x's out and realize that x times x gives us the x squared. And so the square root of 25x squared is 5x. And this is one example of what's known as a perfect square. And I could double check my work by going back and saying, okay, is 5x times 5x equal to 25x squared? Right, so that's going to be 5 times the 5, well that's 25, and the x times the x, which is x squared. Woohoo! We got it right. Here's the beauty of this next one, ready? It's multiple choice. Awesome. All right, as we look at this, right, we want to understand what perfect squares are. Remember, perfect square is when a number that, when multiplied, you can perfectly find the square root. In other words, it's going to be the first term times the exact same term. All right, go ahead and look at this and see if you can solve this problem. And just for kicks, here's one more. Go ahead and simplify this square root, which you've been working with as you were thinking through all of this stuff. That's it for lesson 103.